A common question chemists have to answer is how much of something is present in a sample or a product. If the product contains an acid or base, this question is usually answered by a titration. Acid-base titrations can be used to measure the concentration of an acid or base in solution, to calculate the formula, molar mass, of an unknown acid or base, and then to determine the equilibrium constant of a weak acid or weak base. This lab is broken down into two main parts. The first being a titration of a known acid, potassium hydrogen phthalate, with sodium hydroxide to determine the exact concentration of the base, which we will use in part 2. The second part of this lab will use the standardized base to titrate an unknown acid to determine its equivalent mass in pKa, which can be used to determine its identity. Dilute sodium hydroxide solutions are irritating to skin and eyes. Phenolphthalein is an alcohol-based solution and is flammable. It is moderately toxic by ingestion. Keep away from flames and other ignition sources. Avoid contact of all chemicals with eyes and skin, and wash hands thoroughly with soap and water before leaving the laboratory. get to the equivalence point, it took 30.6 milliliters of NaOH. At this point, the pH was at 7.5. Halfway to the equivalence point was when 15.3 milliliters of NaOH was added. At that point, the pH was 1.86. At the halfway point, the pH is equal to the pKa, so the pKa was 1.86. To find the Ka of the acid, we take 10 to the negative pKa, which is 10 to the negative 1.86, or 0.0138. The second part of this lab is finding the equivalent mass of an unknown acid. The equivalent mass is the grams needed to give off 1 mole of hydrogen. In this experiment, we had 0.397 grams of the unknown acid, and at equivalence point, it took 30.6 milliliters of NaOH, which equals 0.0306 liters of NaOH. To find the moles of OH minus, we will take the liters of NaOH and multiply it by the concentration, which also equals the moles of H plus at equivalence point. Now to find the molar mass or equivalent mass of the unknown acid, we take the grams, 0.397, and divide by the moles, 0.00260, which equals 153 grams